And go. All right, so today we're going to learn how to convert between degrees, minutes, and seconds, and back to decimal degrees, and so forth, so on and so forth. We're also going to talk about what a coterminal angle is. Again, most of trig is just vocabulary, and if you think about what the vocabulary word sounds like, it basically tells you what it means. Okay? All right, here you go. Yeah, all right. So to convert from degrees, minutes, and seconds to a decimal, you just have to remember how many minutes are in a degree and how many seconds are in a degree. So when it gives you in degrees, minutes, and seconds, the degrees part is good. So this is going to be the part. Let me start over again. Yeah, you just bring down the 105 part. Okay. Then what you're going to add to that is you're going to take 20 minutes, but how many degrees, how many minutes are in a degree? 60. So you need to do 20 divided by 60. What's 20 divided by 60? What is it? 1/3, which is what as a decimal? 0.333. Just to be accurate, go ahead and do 4 decimal places. Sorry. Okay? And then when it comes to seconds, so to that we're going to add the seconds. How many seconds are in a degree? 3,600, exactly. So you have to divide this by 3,600. And 32 divided by 3,600? Give me the first 4. 8. And then should we round up to 9, or does it round up to 9 or no? Yeah. Okay. So would you agree that it's 0.0089? Yeah? Okay. Add all that up. What is that in degrees? So 105, right? 0.3, is it 3342 or 342? 342. Okay, so 3422 degrees. I'm going to just cut out that last 2. You can put it in there if you want to, but I mean, 3 decimal places, that's pretty good. Questions, comments, concerns? Is good? Okay, so again, sorry? Okay, so again, you just have to remember how many minutes are in a degree, how many seconds are in a degree, because when you're converting to degrees, it all goes back to degrees, okay? Versus converting this thing to degrees, minutes, and seconds. All right, same thing. As far as the 85 goes, right here, the 85 stays as it is. Okay, so just keep that as your degree. The thing that you are trying to convert is this decimal part. All right, so the next thing after degrees is minutes. Yay? So if this is a fraction of a degree, then you just multiply this by the number of minutes in a degree. So you take that 0.263 and you multiply it by 60. Right? Because there's 60 minutes. Yay? Okay. What do you get? Amen. All right. Now, is that 15.78 in degrees or minutes? It's minutes. So you have 15.78 minutes. Yay? All right. But the 0.78 can be broken down into seconds. So now, if you just take this 0.78 and multiply it by 60 seconds, that'll tell you how many seconds there are in this thing. Let me do this real quick. I'm going to extend this page so you guys can see it. There it is. Okay. So, here we go. Final answer. You have 85 degrees. You have 15 minutes, right? And how many seconds is this? 46.8. Yep, 46.8 seconds. Yay? So putting it all together, it's 85 degrees, 15 minutes, and 46.8 seconds. Notice that per second, you don't need to multiply by another 60 because there's no other, I mean, we don't talk about any other measurement after seconds. So after you figure out the seconds, you're done. If you get to the minutes part and there's no more decimals, then no seconds. Just be 0 seconds, right? Okay. Questions, comments, concerns? All right, let's take a look at this really quick. All right, because going either way is can be a little bit confusing. The first way, you had to divide by 60 for the minutes and 3,600 for the seconds, right? Because you're bringing it back to degrees. Since you're converting degrees to minutes and seconds, then you just go 60 by 60 for the next one, because then the 260s would take care of the 3,600. Burr? Okay, you'll get plenty of practice. All right. More vocab for you. Here you go. Ahem, ahem. A quadrantal angle. A quadrantal angle are the angles that lie on the x or y axis. So if you're thinking about a clock, it's 12 o'clock, 3 o'clock, 6 o'clock, 9 o'clock. Yeah? If you think about degrees, it's just like Banana Hunt, where, it's just like Banana Hunt, where when you're looking at the x and y axis like this, it's at 0, 90, 270, and 360. Oh, sorry, 0, 90, 180, 270, and back 360. Oh, this is not right. Erase. Okay. So 10. Okay, so 180, 270, and then back to the start would be 360. Okay, so those are your quadrantal angles. They're like the easiest angles to solve for on a trig. Make sense? Notice on the Banana Hunt last time 0 was over here and 180 was over here. In trig, we always start with the positive side of the x-axis. That's where the 0 is. Okay? All right. Co-terminals. Let's find a word that means the same thing. Co-workers. What's a co-worker? You work at the same place, right? You work at the same place. It's true. So co-terminal means the angle terminates at the same place. Okay? And by terminating at the same place, it just means that the angles are a multiple of 360. Like you're just going around the circle a bunch of times. So for example, you got it? All right, this blue part, this is the terminal side right here. So if my angle, I'm just going to measure a positive angle this way. And let's say that's, oh, I don't know, 135 degrees. Is that good? Yeah? Another angle, let me change my pen color, could go around the circle, all the way around, and end up back here, and just stop, right? So to get to that angle, you would take basically 135, and then add 360 to it. Can you guys see that on the board? Nope, I'm going to use a different color. Here we go. Yeah, so if you take 135 and then add just another round of the circle to it, this angle is, hello? 495. 495, sorry, 495 degrees. So you can say that 135 and 495 are coterminal. Meaning that they just end up at the same side. They end up at the same rate. Yeah? which sounds incredibly trivial, right? Like, why are we even learning this? Well, if you know that two angles are coterminal and one's incredibly huge, your calculator can only do so much. So, for example, if you were trying to find the sine at 3,520, your calculator is going to be like, no, thank you. You have to find the smallest angle that ends up at the same side. So you just keep subtracting 360 till you get to a small angle. That's it. Okay? So for example, find the angles with least possible positive measure. Okay? So for example, your calculator will not do 1106 if you find sine, cosine, tangent. It's just going to be like, no, you're crazy. So you need to find a coterminal angle. If it's a huge number, like in the thousands, do we add or subtract 360? Subtract. So just take away 360 from 1106, and you get 746. Excellent. Which is still a huge number. Basically, anything more than 360 is too huge. So if it's still more than 360, take it away. And 386. Still bigger than 360. So take it away again. 26. So that angle will have the same value as 26 degrees. Done? Okay, so big, just take it away, take it away, take it away. What happens if it's a negative angle for the small angle? Add. I feel like you know this. This is good. Plus 360, you get 210, right? Stop or keep going? Stop. Exactly. It's between 0 and 360. You're good. Negative 603. What do we do? Ah, we add 360. And Jaleesh, what did you say? Oh, yeah. So it's negative 243. Still negative. So add another 360. What is it? 117 degrees. Yay? So again, make sure you read the instructions. It's the least possible positive measure. So the smallest thing between 0 and 360. Yay? Yay. Okay. All right. Oh, I love this one. Oh, what? Dylan, did you say word problem? Oh my gosh, here we go. A wheel makes 270 revolutions. In other words, it goes around 270 times per minute. How many degrees will a point on the edge of the wheel move in just 5 seconds? All right, so this is a clock thing again. It's a clock thing again. All right, first of all, in 1 minute, it moves 270 degrees, but it's asking for it in seconds. So remember that 1 minute has how many seconds?
60.
Right?
70.
So in other words, 270 rotations in 1 minute is equal to 270 rotations in 60, that's a 60, sorry, 60 seconds. If you divide 270 by 60, what do you get? 22.5 per second. So it goes 22.5 times per second. So how much would it be in 5 seconds? What would you do? Yeah. Sorry, Zara. It's 4.5. Where did we get 22.5 from? Sorry, it is 4.5. You are right. 22 is 4.5. Above 60 seconds? Oh, 270. Sorry, 270. Yeah. All right. Thank you, Zara. Here we go. It's 4.5. Sorry. Okay. So in 5 seconds, right, you just multiply 4.5 times 5, and you get? Yeah. So that would be 22.5 times. Okay. But the question is, how many degrees is that? It's easy. How many degrees in a circle?
So don't you just move it over?
Yeah. Well, no, you don't move it over a decimal place. If it goes around, right, 22.5 times, how many degrees is one time around? 360. So just take that 22.5 and multiply by, yeah. So if you go 22.5 times 360 degrees, 8,100. So it's 8,100 degrees in 5 seconds. Yay? For you future engineers, I mean, yeah. Going around and around and around in a circle. Yes, Miss Page. Kinda. Let's break it down. Yay? Yay? Okay. The problem is given to you in minutes, but the question is in seconds, right? But the question is how many seconds. True? So, I mean, when you're breaking down a problem, try to convert it to the rate that you're actually looking for. So 1 minute is 60 seconds. So if you're converting what it says here, 270 per minute, then just convert it to 270 per 60 seconds. Yay? And then it's just a division problem. And then after that, find out how many 5 seconds worth. Remember, rotation is 360. So in breaking down to the problem, you just have to figure out what parts pieces are relevant, and then go from there. Okay? Yeah. It's all right. I'm here for you. Okay. All right. Everyone has their textbook, correct? Okay. There you go. Got some time. If you get it done today, turn it in.
Fun.
Fun.